All right, welcome. We're going to start a unit with quadratic equations, and we're solving quadratic equations. The first one is going to be the square root method. So you're going to learn how to solve simple quadratic equations using square roots. The idea here is that there is an x squared, no x, so there's no x here, and you can say equals a number, plus or minus a number, anything like that. But the key is that there is no x. Okay. So first off, let's get a perfect square table. This might help you understand some things here. You should know your perfect squares, like 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16. I might let you have this table on your test, so you might want to make sure you copy that down. So you can pause this right here to get that. Alright, so first off, let's talk about what does it mean here with square roots. Okay, so say you have an equation. Here's a very, very simple equation. X squared equals 49. Okay. Everything has an opposite, like an inverse. So like when you say like, okay, 3x, 3 times x, the opposite of 3 multiplying by 3 is divided by 3 to solve. Here, the opposite of a square is a square root. So I take a square root, and that would cancel out the square. But if I'm doing it on one side, I got to do it on the other side. Now, algebraically, when we take a square root, we will always put positive and negative. So like the square root of 49 is 7, but I'm going to say plus or minus 7. So basically I'm getting two answers, one positive 7, one negative 7. And you can check your work, so I'll show you how you check it. You're going to put the 7 in place of the x, and notice that when you square both of them, positive 7, negative 7, you get 49. So that means both answers were correct. That's why sometimes you get two real answers and you have a positive, two numbers there to find an answer for it. Alright, so let's also bring up the idea what happens when you have a negative. And we're going to go further into this later, but basically when we see a square root of a negative number, we're going to say it's the square root of negative 1 and the square root of 16. Like we're going to separate the negative from the number itself. The square root of 16 is 4. I'm not only going to put the 4 now. I'm not going to put plus or minus because right now it's not equal to x. So the square root of 16 is 4, and every time you have a square root of a negative, you're going to put I. That is the symbol for the square root of negative 1. So that's basically the symbol we use when we take negative square roots. Okay, so if I had x squared equals negative 16, I could say plus or minus 4i. Again, I is going to be the symbol we use for x, or square root of negative 1. So basically the square root of a negative. Every time you see a negative number in a square root, you will put an I. Alright. So let's say something simple. Okay, so x squared equals 64. Square root of that would be 8, so it would be plus or minus 8. X squared equals negative 25. Square root of 25 is 5. With the negative would be plus or minus 5i. So there you go, fairly simple. Alright, now what happens if they're not perfect squares? Because, well, of course I'm going to give you some that are not perfect squares. Then you have to simplify square roots, and there's two methods that we use here. There's your perfect square method, and then there's your factor tree method. I kind of prefer the factor tree method, but I'll show you the perfect square method also. Okay, so what the perfect square method is, it says you take that table that you had earlier, that table, and you're going to divide, oops, you're going to start seeing which of those perfect squares can divide into 60. Well, 49 doesn't, so I cross that out. I look back at the table, the next number is 36. That doesn't divide into 60, cross that out. And you just keep going until you get to one that works. 4 works, and when 60 divided by 4, you get 15. Okay, so I can take the square root of 4, which is 2, and I can leave the 15 under the square root symbol. On a factor tree, what we're trying to do is that we break it down to prime numbers. Well, I can see 60 and 10 is 6 and 10, or 10 and 6, whoops, and there you go. 10 would be 2 and 5, and 6 would be 2 and 3. You break them down to prime numbers, and then you can rewrite them, and what you have a pair of goes on the outside, what you have left over multiplies and stays on the inside. The pair, what the pair was, goes on the outside, so keep that in mind. So here's like square root of 98 here for both methods. Okay. I try 81, that's under 98. That doesn't work. This is the perfect square method that I'm doing here first. 64 is next. That doesn't go into it. 49 does. 49 goes into it 2 times. The square root of 49 is 7. Square root of 2. Factor tree method, you would say, okay, 2 goes into that 49 times, 2 doesn't go into 49, 3 doesn't go into 49. You look for prime numbers that can go into something. 7 does, and that would give you 7, 7. So you would have a pair of 7s. That means that goes on the outside. You have a 2 left over that doesn't have a pair to go with it, so it would stay inside the square root. So notice how they both come up to the same answer, just different. So a little practice with it and you should be okay. Alright, so let's solve some here. Okay, so what's the idea here? This is just like a regular equation that you've seen before. The idea is to say solve for the x squared, and then when you got x squared by itself, then you can take the square root. So I'm going to subtract 17 from both sides. It's going to give me 80, and then I will take the square root of 80. Now, square root of 80, I'm going to get plus or minus, and then I would say use whatever method I want to use. In this case, I'm going to use the factor tree, and say 8 and 10. Well, 8 is 4 and 2. 4 is 2 and 2. So notice I keep breaking it down until I get nothing but prime numbers. 10 is 2 and 5. So I have those prime numbers right there. I have a pair of 2's and another pair of 2's. So that means I'm going to multiply those pairs. What is the pair of 2's? 2 times 2 gives me 4. And then I had a 5 left over, which stays under the square root symbol. And there you go. Plus or minus 4 square root of 5. What happens if I put a number in front of the x squared? Well, again, treat it like you normally would. Subtract the 13, divide by 3, then you can take the square root. Now that I have the square root by itself, I can take the square root, and you can see how I'm coming up with the answer. Notice here that I broke it down to 5 and 10. Anytime I have a 0, I'm going to say that number with a 10. And then I'm going to say 10 is 5 and 2. Those are my prime factors. And then I would say, oh, I've got a pair of 5s, so that's going to go in front. And I have a 2 that would stay inside the square root symbol. Another example. Okay, here I'm going to subtract 7 and then divide by 3. Notice this one's negative. So what's the square root of negative 16? Again, the square root of 16 is 4 plus or minus. And then because of the negative, I would put a 9. This is about as complicated as I can get these, by the way. So just kind of keep that in mind. So here's my last example. Slightly bigger number. I'm going to subtract 5. Then I'm going to divide by 2. Then I can take the square root. And when you take the square root, okay, you know you've got an I. And you got a square root. Notice that it's going to be like number I square root symbol. Like the square root symbol is always like kind of at the end. Okay, so I'm going to break down 147. Well, 2 doesn't go into that. 3 does. 3 goes into it 49 times. Oh, that was nice. And then 49 is 7, 7. So then I can say 7, because that's a pair of 7's, square root of 3. So 7i square root of 3, plus or minus. That's really about it. So if y'all have questions, feel free to ask. We will start with simplifying square roots first. Then we will worry about solving them like another day. Okay? Anyways, y'all take care. And that's it for today. Thank you very much.